Hello everyone, welcome to Software Testing Mentor and RCV Academy. Today I'm going to start a brand new series on manual testing interview questions and answers. This is a comprehensive list of manual testing interview questions and answers for the freshers. So I'll be starting from very basic for the fresher whosoever is looking for the job in software testing. So I'll be starting from there, and then I'll be covering the experienced interview questions that are asked to the test leads, test manager, and any role that is at the higher end of the career. So for example, you are targeting the test lead and manager level role after 7 to 8 years, then you can basically go ahead and answer those sort of behavioral and project level questions as well. So as of now, I have prepared almost 100 questions, and this particular series will be published in different parts or different videos, and each video will cover or contain almost 10 interview questions if the time permits. If the discussion on those questions is long, there might be less questions. Now, how this overall series will evolve? So whatever questions I have with me, I have prepared, I'll be sharing all of those answers with you. Now, if you feel that after end of this series, or when I announce the last video of this particular series, that yes, we have to cover more questions, or you have been asked some more questions in the interviews you weren't able to answer, or you want more clarity on, you can comment, or I'll publish a particular channel wherein you can comment those questions, and I'll keep preparing more interview videos on manual testing interview questions and answers. So this will be ongoing series and lot more to come, so stay tuned and let's get started with this particular series. So what all are we going to cover in this particular video of part 1 of manual software testing interview questions? We are going to cover very basic questions. What is software testing? Importance of software testing, objectives of software testing. Then why do we say that software testing is context dependent, and some of the causes of software defects. What are different levels of software testing? Then we'll cover unit, integration system, and acceptance testing. So this is what these 10 questions we are going to discuss in this part 1. Now, if you are in any of the interviews and any of these interview questions are being asked, you will be able to answer them very efficiently. Okay, so let's understand what is software testing. Right now, practically, if you have to go through and review these slides, I'll share anyway. So once the series will be completed, I'll share the link to download the slides. But practically, say for example, in general, when we say testing is something, or in a general context, you are ensuring that the product that should be released is actually able to fit the purpose or fit for use for the customer, right? So whatever customer is looking for, you are providing that quality product or service. That's in general testing for any of the application or hardware or software, whatever you say. Now, when we say software testing, when you perform the same fundamentals, or the purpose is same, that your software or the application that you are releasing to the customer is able to satisfy the end user needs, it is not breaking, or it is able to perform in a particular relevant way that the customer expects. That is what your job as the software tester is. Now, when we say about some of the definitions, so software testing is a process of evaluating and verifying that the software does what it is supposed to do, right? That's the first thing. Second thing is, it also determines the software is fit for use. Okay, so if the customer is looking for a registration application so that they can fill in, or student registration application in the school, and the school wants to register new users or new students in their student database, they are looking for the application that has the user interface. They can fill in those details, student details, and when they hit register, the user should get registered successfully. The registration details should get stored into the database, and they should be able to retrieve those details later. So this is what one of the fit for use criteria for a user or a student registration for a school software. Now, as a software tester, when you are ensuring that this particular registration software fits or in the school context is able to make sure that yes, it will help the school to register new students and retrieve their information later, then that is fit for use. So whenever you are testing any of the application or software, you are also ensuring that it is actually fit for use for the end user or the customer that will be using it. Okay, now software testing also helps in preventing defects, right? You as a software tester not only just go ahead and test something by executing it. As the software tester, your role and your responsibilities start well ahead in the software development lifecycle. You provide inputs to the development team, and because of those inputs and because of those discussions and gaps are identified, and with those inputs and discussions and the scenarios that you as a software tester write and discuss, it helps in identifying any of the gap and prevent defects in future when the developer starts coding or the design is happening. In that phase, the software testers help in preventing defects. And software testing helps in finding defects and failure. That's obvious, very obvious, statement that you can put when somebody asks what is software testing. Software testing will help you to find defects and failures as well, in case something by mistake has been missed by the developers, by the designers, even after discussing or having a lot of conversation, which usually happens most of the time. Then software testing, when during the execution phase, you can detect the defects or failures in the application by executing or by running that particular application. So this is a brief answer about what is software testing. Now, what is the importance of software testing? Now, many times software testing, or the best statement to make the importance of software testing, is that software testing saves money. Why software testing saves money? Now, many people will feel that software testing is an overhead. It shouldn't be there actually, and that's very old school management that has always sort of believed it, but now it's no more a case. The reason being that software testing actually helps to save money. Now, if you have identified, or as a software testing team, you are involved early, which is most of the cases because of the agile software development approaches nowadays. So testing gets involved very early, and because of the testing inputs, there are a lot of gaps in the requirements in the design that are identified well in advance. And because of that, those defects are not then going or flowing ahead into the development and into the actual product. And if these defects are not going ahead or are fixed early in the cycle, the cost of fixing these defects is far less as compared to defects that will be identified in the later phases of the software development lifecycle. A production defect can cost almost 10 to 100 times more cost as compared to the same defect that is identified in the requirement or design phase to fix and remediate it. So that is where the software testing, if testing has detected and ensured that, out of 1,000 test cases, they say, for example, they have identified 100 defects and 100 defects have been fixed, you can imagine the cost of these defects if these defects would have been gone to the production and would have basically be able to be fixed into the production, or after going into the production. You can imagine how much cost would have been involved to again go back and fix all of this, right? So it's kind of whole cycle. So if these defects are the coding defect, or if they are a design defect or a requirement defect, then all of that whole cycle needs to be done, and everyone who was involved in the SDLC needs to be paid again to fix these defects, right? So that is where testing actually saves money. Best statement to make when somebody asks what is the importance of software testing. It will help you to save money. It helps to improve software quality. Now, because you are detecting or identifying gaps and the defects during the software development lifecycle, so overall eventually the quality of the software is improving, right? Then it also enhances the development process. So software development process is enhanced because of the inputs from the testing team, right? So this needs to be understood as well. And software testing helps in ensuring security and performance as well. Now, software testing is not just manual testing or automation testing. It's a broader concept, right? And this software testing ensures that your security of the application is maintained. There is a security testing that cycle that happens. There is a performance testing cycle that happens. And all of this ensures that the security and performance of the application is also intact and is up to the mark. So this is what the importance of software testing is. Now, what are some of the objectives of software testing, right? Now, most of these, some of these statements might overlap in one or the other, which is absolutely fine, okay? Because these points you can make in either of that, if in the importance or exactly in the objectives as well. So objectives of software testing is, the first thing is that it helps in preventing defect, okay? Now, because of you being the tester in the team, you help in analyzing the requirement, analyzing the design document, analyzing the other documents that are available, and then based on that you come up with the test scenarios, and that is kind of a input to other developers who are developing, or the solution architects, or the requirement whosoever business analyst. So in case there is a gap, they can right then and there fix it, okay? So that helps in preventing defect. Then software testing determines that the software is fit for customer and end user, okay? So it actually does what it's supposed to do, right? Now, when we say fit for customer or end user, so imagine you have a car, okay, and the requirement says a car should have 4 wheels. Now, as the software tester, you will ensure that the 4 wheels should be at the right place and in right alignment for the car to move, okay? This is what you as a tester will help to achieve. But if the requirement doesn't articulate well where exactly the car should be, what should be the alignment, this is what you will identify as the tester, that I am going to test that the car actually moves with the 4 wheels, okay? And wheels are aligned at the right place, not at the roof of the car, right? So when we say fit for customer, fit for end user, then this is what testing ensures, that yes, even though the software meets the end user or meets the requirement which is fitting in the 4 wheels in the car, but they should also be fitted in the right place, not at any of the place which is basically matching or making sure the requirements are met, right? So software testing is not just ensuring that the requirements are met, but also ensuring that whatever requirements are there, they are met in a way that makes sense practically and it's fit for use to the customer and end user, okay? And then software testing helps in finding defects, bugs, failure, any of that during the whole development life cycle. Software testing builds the confidence in the application because defects are found, fixed during that whole software development life cycle. So the overall confidence in the application is also built. And software testing reduces the risks because you have tested the positive flow, negative flow for your application. You know that the application actually works. If I'm going to do the registration of the student, I have myself as a tester gone through, put in the student application details, submitted the application, and then ensured that the details are getting saved into the database. When I try to retrieve those student details, I am able to retrieve it. So when you have done it practically during the testing cycle, you obviously know that it's going to work in production, right? So it reduces the overall risk of that thing, that whether it's going to work or it's not going to work, right? That speculation will reduce. So this is about the objectives. Now, when we say, why do we say testing is context dependent? Next question, right? So next manual testing question could be, why do we say testing is context dependent? So context dependent because the approach and thoroughness to test any, say for example, I host a tutorials website, okay, and then there is an air traffic control system. Would you test both of these with the same level of thoroughness and the approach? Not at all, right? Because air traffic control system is very critical system. Many lives are dependent on it. There will be regulatory requirement and the compliance requirement that you have to meet for that system. But a tutorials website is just for hosting the blogs and tutorials. So the context of testing or the approach of testing tutorials website will be different as compared to the air traffic control system. So this is why we say that testing is context dependent, depending on which context the application is tested for, you will apply the principles, practices, and thoroughness in that particular context, so that the application that you are testing actually is tested thoroughly depending on the context. Okay, so this is why testing is context dependent. Now, what are some of the causes of software defect? Another practical questions though, it might be asked that explain me why do software defects arise, or what are some of the causes of defect. So the first thing could be, the requirements are not clear. The requirements are not articulated well. That's the entry point of something, right? So if the requirements are not articulated well, there is not more information or appropriate information, relevant information mentioned in the requirement, that may be one of the cause of the defect. Now, if these requirements are not cleaned and cleared right up front before the development starts, with those unclear requirement, development will happen, developers will code according to that, and obviously that product is not going to fit customers' need. So that is the first and foremost thing. You can answer that maybe because of the unclear requirement or unclear understanding about the software purpose. So when we say software purpose, it is important to understand why the software is being built, or whenever you go in any project, right? You need to understand why you are working in that particular project, what is the purpose of this particular project and the application, what it will solve, or what is the problem statement and what this particular application is going to solve for its customer. So understanding who are the customers, first thing for your application, okay, in whichever project you are working, that's the first and foremost thing. And second thing is understanding that whether these requirements that you are reading now are actually articulating the right level of personas and the flow that will ensure that those end user requirements will be met, right? Or end customers' need will be met, right? So unclear understanding is another cause of software defect. So if there is unclear understanding about the software purpose, then obviously the real purpose of the software won't be met. Now, another thing is miscommunication within team. This is very common. If your team is not working in a collaborative way, there is a blame game and there is a miscommunication, then that is another cause, because developers doing something, they are not taking inputs from the tester, and then tester is just not providing proactively input. That is another problem because of which defects can arise. Then obviously mistakes by people, right? So it doesn't matter how streamlined your processes are, how collaboratively you work, but then there are few mistakes that happen during that process. Everyone is human being. Mistakes happen in the requirement phase, in the design phase, in the development phase, in the testing phase as well. You can miss some of the defects. It's pretty obvious, right? So because of the mistakes or misunderstanding during that SDLC, there might be defects. Less skilled team. So if you're building, very complex application and you do not have the right skill set within the team, obviously the defects can arise because the team is not skilled. Team will, learn something. They are not up to the mark, and because of that there will be defects. Then there might be external factors. For example, your system is all good, but when it's integrated with third-party system, the issues are in the third-party system. Integration interface is not going to work. So external factors could be the reason of the software defects as well. Now, what are different levels of software testing? So different levels of software testing, there are 4 levels of software testing: unit, integration, system, and acceptance. Okay, so these are only 4 levels of software testing in which most of the testing that you do, or the types of the testing, will basically fit into these 4 levels of testing. All right, so very important question. Whenever you are asked what are different levels of testing, 4 levels, and types are many. Testing types are many, types of testing are many, but levels are only 4: unit, integration, system, and acceptance. Okay, now let's see the 7th question. So which is, what is unit testing? So when we say unit testing, so unit stands for the smallest testable part of a software. Now if we talk about software, it is smallest testable part of the software. If we talk about any other device, hardware, anything that we are testing, it is the smallest part of that hardware that you can test independently. Okay, now I'll take an example of the car, okay, car wheel, say for example, you are supposed to test the car wheel. Now when you are testing the car wheel, think about what is the smallest testable part of that particular wheel. So you'll think, okay, the rim is the smallest testable part, or the tire, or the complete, wheel. No, it's not. Like the tire is separate, right? Then tube is separate, the rim is separate, and within the rim there'll be smaller part, which is basically the bearings as well, right? So bearing is kind of, you can say, it is smallest unit that can be tested independently, right? So that bearing, ball bearing, is the smallest testable unit which can be tested independently, right? Now if you say that within bearing as well, I can go ahead and break it and test internal contents of it, that is again, you can go up to that granular level. But from the testing perspective, when we say the smallest testable part, right, the other testing that is done within that bearing is more of a material testing, or how strong those ball bearing items are, and the material is, that is separate. But if we talk about a unit as a whole, the bearing is the smallest unit that can be tested about the lubrication, how the rotation happens, if, say for example, how many rotations can happen in particular a second, right? So all of that in a smallest testable unit is a bearing. Okay, when you're testing that bearing, it's a unit testing in a car context, in a car's wheel context. Okay, now in the software context, we are doing the similar thing. When you test the smallest testable part that is independent, that can be tested independently from all other integrated items, that is what the unit testing is. Now unit testing is done to validate the lowest independent entity works as expected. Okay, so whatever the lowest independent entity is that works expected, that is what unit testing is. Now if, say for example, you have to give an example in the software context, you can say that if we say unit testing from the developer context, okay, from the developer, usually unit testing will be done by developers, because it's a more of a white box testing wherein developers go through their code and their functions and method that can be tested independently. For example, in a calculator application, they have written certain methods: add, multiply, divide, all of those methods. Now add method, you can simply pick, and that method can be tested independently by passing different arguments to the add method. So that's what usually unit testers or developers do. They pick that particular method, write unit test code to pass on the arguments to that code, and then verify the output. Okay, this is the lowest independent entity for developers. If I talk about unit testing from the testers context, now I segregate it separately from unit testing from developer and testers perspective. But usually in the industry, when somebody says unit testing, it is the testing of the smallest unit or a method or function that can be tested independently. But from testing context, I can think of, for example, I am testing a e-commerce website, and then there is a registration module, right? And registration module that I am testing is having different registration options, Google, Facebook, Twitter, and then registration using email. So if I'm going ahead and testing the smallest testable part of the registration or smallest testable flow of the registration, it could be just going through the registration functionality from the email, right? Then that is something which is kind of black box for me, but I can go ahead and test it independently, and it could be a component level testing. I won't say it is a unit testing from the testers context. Unit and component are used interchangeably, but sometimes component in software testing is mentioned to identify from the tester's perspective the component as a unit that tester can test, right? So this is briefly what a unit testing will do for you, or what a unit testing is. It is done to validate the lowest independent entity. It is the smallest testable part that is isolated and tested independently. And stubs and drivers are used to replace missing component. That is another important thing which I'll cover in what is stubs and drivers in another question. So now the next question is, what is integration testing? Okay. So integration testing tests the interfaces between units. So when you have tested a unit, okay, so for example, you have tested the ball bearing. Now ball bearing independently doesn't make any sense, right? It needs to go into the wheel of the car. Okay, so on the ball bearing there will be some setup with the rim. Okay, so when you integrate that ball bearing with the rim and then test that interface together with the ball bearing, how everything is moving, that is what integration testing is. So when interfaces between two units or more than two units is tested by interfacing the units, then that is what integration testing is. And the focus of the integration testing is to test the interactions with other integrated units, components, and the interfaces. Okay, for example, the login module. Okay, registration, you are testing the registration module. So registration module, consider it is, for example, a unit. After registration, you are testing the login module with that registered user. So you registered and then you try to log in using that user. So that is kind of an integration testing for you as the tester, right? But then you can go, any level of detail within that integration. So from the developer's perspective, it is more of if multiple units are being integrated together and then the developer is testing all of that whole code at once, that could be integration level testing for the developers as well. Okay, now what is system testing? Now system testing is the next level, right? So unit is the lowest level, integration system testing is next level, which tests the behavior of whole system as per defined scope. So whatever scope has been defined in the requirement for a system, when you are testing that whole system as a whole, that is known as system testing. For example, e-commerce application, a whole full-fledged system will have registration, will have login functionality, will have add to cart, will have payment, will have shipment, right? Tracking of the shipment. When all of these modules are available, built, available together to test this whole end-to-end system as a whole, then that is known as system testing. And system testing should investigate both functional and non-functional aspects of software. It is not just the functional. When we say functional, it is verifying the registration is happening when the customer puts in details and clicks on register, verifying the customer can log in. That's the functional aspect. But then non-functional aspect is how quick the response is when user clicks on register button. Okay, is user getting the response quickly, or user has to wait for 30 seconds to get the response, right? So all those non-functional aspects, security, performance, everything needs to be tested as well. So that's what system testing is. Now what is acceptance testing? So acceptance testing is the last level, I would say. So in the test level, you have 4 levels. So unit, integration, system, and acceptance. So acceptance testing is the testing level wherein it is done mostly by customers and stakeholders in collaboration with the development team or independently. So it could be that development team is helping, right? So if it is, more of a alpha testing, which is type of acceptance testing, then development team, it is within the premises and development team might help a little bit. But mostly acceptance testing is done by the customers and stakeholders and independently to ensure that the application that is being built is actually satisfying the customer's requirement that the customer has articulated and what customers actually expect, right? That's where user acceptance testing, that's why it is acceptance testing. I'm going to accept it if it is fulfilling my requirement or my needs, right? If I'm going to buy something from the market, I'll do a quick round of reading through the manual, right? So I have certain criteria in my mind. Okay, now I'll see that whether this particular, say for example, I'm buying a phone, whether this particular phone is satisfying the criteria, right? So whenever we go to buy a phone, we see I need to buy a phone with 1 terabyte of storage, 16 whatever RAMs, whatever processor size I'm looking for, whatever, if a specific brand, and then cost range as well. Then if all of those tick boxes are ticked, then it is acceptable for me, right? So that's same process happens in the software as well. So customer has articulated their requirement initially when the developers or the team starts building something. When they have built that whole software, the customer then checks that has this particular application been able to satisfy what I have articulated, as well as is it fit for me, or when I'm using it now, is it acceptable, or it is of a decent quality and performance, so that I can go ahead and accept it, right? So this is what acceptance testing is. Acceptance testing is done to check if software fits end user needs, establish confidence in the application, right? And it ensures to that software meets the compliance and regulatory requirement as well. It's not only about it fits my need. It should be, if say for example it's an air traffic control system, if it is a medical software, whether the software has matched or met the regulatory government regulations or the compliance requirement or not, right? So that is also part of the acceptance testing. And acceptance testing helps to make go or no go decision, whether this software can be released into the market. If it meets all those criteria, yes, it can go. If it doesn't meet any of those criteria, or some criteria are not met, then yes, acceptance testing will fail, and the vendor or the development team has to fix those before it can be released to the market or the end user, to the customer or end user. So this is what acceptance testing is all about. Okay, so these are 10 manual software testing interview questions, which is part 1, which is only part 1 of this particular series. I'm as per my identification of the number of questions that I have till now, I'm looking for around 20 videos to come in this particular series, which will be having almost 200 questions, and then the questions from you guys, whatever questions will come, so we'll be covering that. So I believe this will be an ongoing series and will be very helpful for the whole software testing community. So please go ahead, comment if there is something that you came across in your project and you want to add on. Okay, in the answers, go ahead, comment, so that it's helpful for everyone in the software testing community. Now in the next video, I'm going to cover 10 more manual software testing interview questions, which are listed on this particular screen. So stay tuned. I'll be covering these 10 questions in the next video, which is part 2. So that's all for this particular video. I hope this was helpful. Thank you very much for watching. Please do share and subscribe if you haven't already. Thank you.